Most people assume they understand what blood type O really is, the so-called universal donor, that straightforward category credited with saving lives when things get critical. But when artificial intelligence recently worked through enormous volumes of genetic and medical information, the true picture of O turned out to be far more unexpected than anyone had anticipated. Concealed patterns, remarkable health connections, and evolutionary surprises are now reshaping what we once considered settled knowledge. So let's get into it, because after this, you may never see blood quite the same way. Blood type O, it's one of those things where the moment you hear it, your brain probably lands on one of two familiar ideas. Either it's the universal donor, or it's simply the most widespread blood type on the planet. Neither of those things is incorrect. But the actual story hiding behind O blood runs deeper, gets stranger, and is considerably more fascinating than anything a standard textbook would tell you, thanks to years of scientific research and now artificial intelligence sifting through enormous medical databases. We've come to realize that O carries a whole collection of quirks that don't exactly match its reputation for being simple. So, starting from the foundation, human blood is organized into four primary categories under what's known as the ABO system, AB, and O. These groupings come down to tiny chemical markers called antigens, which sit right on the outer surface of your red blood cells. Picture them as little identification tags your cells carry around with them. Type A displays the A antigen, Type B carries the B antigen, Type AB wears both of them together, and Type O, well, O arrives wearing neither. That's precisely why researchers often refer to it as the null blood type. It appears empty, almost like a cell that forgot to put on its identification badge. And that very blankness, as it turns out, is the source of O's remarkable power in medical settings. Since O blood carries none of the A or B antigens, the immune systems of most recipients don't mount a strong reaction when O-type blood enters their system. That's precisely how O earned its reputation as the universal donor. In emergency rooms across the globe, when medical staff have no time to determine a patient's blood type, they turn to O negative as the safest available option. It's quietly been saving lives for many decades now. But here's where the story takes a genuinely captivating turn. O blood isn't simply a humanitarian hero. From a genetic standpoint, it's also a remarkable mutation. Researchers believe the O type came about when a gene responsible for generating A or B antigens lost a portion of its coding instructions thousands of years back. Put simply, O didn't arrive first. It's more like the rebellious offspring of the blood type family, and yet today, O has grown into the most widespread blood type across the entire planet. Approximately 45% of people in the United States carry type O, and in certain areas of South America, that figure can rise to nearly 100%. Clearly, being blank comes with some real advantages. There's another interesting twist, though. O isn't the dominant type everywhere. Across parts of Asia, Type B holds a surprisingly strong presence. In certain corners of India, Type A takes the top spot. These shifts in global blood type distribution offer us compelling hints about human migration patterns, survival strategies, and even resistance to disease. In regions historically burdened by malaria, for instance, blood type O appears to have provided a meaningful advantage. Those with type O were less prone to experiencing severe, life-threatening forms of the illness, giving them a survival benefit that helped the type spread through populations across thousands of years. Naturally, O blood carries its own set of quirks and vulnerabilities. While it may offer some protection against conditions like malaria and even reduce the likelihood of certain clotting complications, it also leaves people more exposed to other issues, such as stomach ulcers triggered by Helicobacter pylori. In other words, nature rarely hands out anything without strings attached. What genuinely shifts the conversation today, however, is the arrival of artificial intelligence into this field. For many years, blood typing was fairly uncomplicated. Were you A, B, AB, or O? So, is blood type O positive or negative? That question has been answered. But now, artificial intelligence is scanning enormous worldwide databases, detecting patterns that human researchers simply couldn't see on their own. And it turns out, even within what seemed like the blank category of O, there are hidden variations, subtle differences at the molecular level, and unexplored links to health outcomes that science is only just beginning to understand. For a long time, we've regarded O as the no-frills, keep-it-simple blood type, but increasingly, it's looking like the complete opposite, a genetic tale packed with survival, mystery, and surprising complexity. And artificial intelligence is finally drawing back that curtain. Keep watching. For decades, physicians approached blood typing as though it were a fully settled field of science. You were A, B, or O. Throw in the plus or minus for your RH factor, and that was essentially the whole story. Straightforward enough, right? Well, not so much anymore. Artificial intelligence has a knack for prodding at things we assumed were simple and exposing hidden layers beneath the surface, and blood type O turned out to be absolutely loaded with surprises. So what exactly did AI manage to uncover? The first major revelation is that O isn't nearly as uniform as everyone assumed. For a long stretch of time, scientists grouped O blood under one broad category, essentially treating every person with O type as though their blood were completely identical. But AI-powered analysis of genetic and molecular data has revealed that subtle subtypes exist within O, and they don't always behave in the same manner. Think of it like discovering that your beloved plain vanilla ice cream actually comes in dozens of slightly distinct varieties, differences far too delicate for the human tongue to notice, yet significant enough to carry real weight in medicine. Among the most fascinating findings is how these O subgroups interact with infectious diseases in different ways. For instance, it was already understood that people carrying O blood appeared somewhat less susceptible to severe forms of malaria, a trait that very likely helped the O type spread widely across regions where malaria was historically a devastating force. What AI analysis has uncovered goes even deeper than that, though. Certain O variants appear to provide stronger defense against cholera, a disease that has left a trail of devastation across human history. On the other hand, some O subtypes may raise the likelihood of serious viral encounters, like norovirus, that well-known stomach bug that tears through schools and cruise ships alike. Then COVID-19 threw even more into the mix. Early research suggested that people with O blood types might be somewhat less vulnerable to the worst outcomes compared to those with A or AB types. Deep learning models powered by AI, which combed through enormous hospital data sets, confirmed the pattern was genuine, but also revealed that not every O type benefited in the same way. Those hidden subgroups that AI brought to light, they actually shifted outcomes in meaningful ways. Put simply, claiming that O blood shields you from COVID is a dramatic oversimplification. The reality is that certain O types fare better than others, and only AI had the raw processing power to dig through millions of records and catch that distinction. Here's another surprise. The so-called universal donor title isn't quite as ironclad as we always assumed. While O-negative remains the safest choice in emergency situations, AI examination of transfusion records reveals that even O blood can carry subtle molecular differences that occasionally provoke immune responses. Those reactions were long brushed off as outliers, but with AI detecting patterns across worldwide databases, it turns out they aren't random at all. They connect back to concealed variations within O subgroups. That discovery could fundamentally reshape how hospitals screen donated blood and pair donors with the right recipients. Even more intriguing, AI has begun charting how O blood interacts with the gut microbiome, the vast community of trillions of bacteria residing within our digestive systems. Early studies point to the possibility that O blood types may support a somewhat different balance of gut microbes when compared to A or B types, which could help explain why people with O blood tend to be more susceptible to ulcers, yet may face lower odds of developing certain metabolic conditions. That's far from just a fun fact. It could eventually influence how personalized nutrition and medical treatment are approached. Picture a future where your doctor doesn't simply ask about your allergies or family background, but also wants to know your precise O subgroup before deciding on a course of treatment. Perhaps the most fascinating piece of all this is what it signals for precision medicine. Up until now, the ABO system has been handled like a broad, rough instrument, helpful certainly, but not especially fine-tuned. With artificial intelligence uncovering hidden layers, O blood is no longer a single neat category. It's more of a range. Doctors may one day be in a position to say, you're not simply O positive. You carry a specific molecular profile that makes you more resistant to one condition, but more vulnerable to another. That degree of detail could transform how we approach preventive care, transfusions, and even organ transplants. And here's the real kicker. We've barely begun to scratch the surface. Artificial intelligence flourishes on large volumes of data, and as more hospitals, blood banks, and genetic databases begin pooling their information, the full picture of O blood will only come into sharper focus. What surprises us today may simply be standard medical knowledge tomorrow. What was once considered the plain, no-nonsense blood type is suddenly emerging as one of the richest and most layered stories in all of human biology. The next time you hear someone casually mention, "Oh, I'm just type O," you'll already know the real story. There's simply no such thing as being just O anymore. O and human evolution. If O blood type has one truly big mystery, it's this. Why did it become so widespread? After all, it originated as a genetic mistake, essentially a missing piece in the gene, responsible for coding A or B antigens. By that reasoning alone, you'd expect it to be uncommon, perhaps even fading away over generations. The reality turned out to be quite the opposite. Type O swept across populations at a remarkable pace, eventually becoming the dominant blood type across large portions of the globe. Clearly, carrying type O gave people some kind of meaningful advantage. One widely discussed theory suggests that O blood provided a kind of shield against infectious diseases. Keep in mind, those antigens sitting on red blood cells aren't just incidental features. They actually influence how harmful organisms interact with the human body. Take the malaria parasite, Plasmodium falciparum, as an example. It tends to grab onto antigens found on red blood cells. People with type O, who simply don't have those same attachment points, are much harder to target. Research has demonstrated that individuals with type O are considerably less likely to experience the most dangerous complications tied to malaria, including cerebral malaria. That might help explain why type O appears so frequently across Africa and other regions where malaria has historically been widespread. Put simply, O may have kept people alive when survival was on the line. But malaria alone doesn't tell the whole story. Cholera, another devastating disease throughout history, also appears to have played a role in shaping how blood types are distributed around the world. Studies indicate that people with type O actually face a greater risk of severe fluid loss when struck by cholera, which on the surface sounds like a serious drawback. And yet, strangely enough, type O continued to thrive even in regions where cholera was a constant threat. So how does that make sense? This is precisely where the picture becomes both complicated and genuinely intriguing. Certain researchers propose that although type O individuals may have fared worse during cholera outbreaks, they might simultaneously have held stronger resistance against other illnesses circulating at the same time. In the language of evolution, everything comes down to trade-offs. There's also the long-standing question of whether O was actually the very first blood type to exist. For a long time, textbooks quietly suggested that O likely came first, with A and B emerging afterward. After all, it's the most common type. Shouldn't that point to it being the original? However, genetic research tells a different tale. Type A is now considered the ancestral form, with type O appearing later through a mutation in the ABO gene, occurring thousands of years back. Even so, once it emerged, type O expanded across populations with remarkable speed. Population genetics models powered by AI now indicate that O's widespread prevalence came partly from random genetic drift, but natural selection played an equally significant role. Put simply, carrying the O blood type improved your odds of pulling through certain epidemic outbreaks, so the trait kept getting handed down. Geography has an enormous part to play in how O is distributed across the world. Across South and Central America, O is almost completely dominant. Among some indigenous communities, the frequency of O blood approaches 100%. So how did things end up that way? Migration patterns are where most theories point. When early humans made their way into the Americas tens of thousands of years ago, those small founding groups already carried high proportions of O, and across countless generations, it grew into the overwhelming majority. Meanwhile, regions across Asia show a much more even spread among A, B, and O, suggesting different survival pressures and distinct waves of migration shaped things there differently. What makes this even more fascinating is how AI keeps throwing fresh surprises into these evolutionary questions. By examining DNA pulled from ancient remains and measuring it against modern genomes, AI is giving scientists the tools to map how blood types transformed over millennia. It feels like watching a time lapse of human survival in action. In certain instances, it even reveals how conflicts, devastating plagues, and large-scale migrations completely redrew the blood type landscape of entire continents. O wasn't simply along for the ride through human history. It was woven into the very fabric of who endured, who didn't, and who carried their genes forward. Then there's the matter of diet, which is a contentious yet genuinely fascinating angle worth exploring. You've likely come across the so-called blood type diet, which argues that people with O blood should consume higher amounts of protein because their ancestors lived as hunters. Most scientists brush this off as pseudoscience, but buried inside it is a small grain of evolutionary reality. O blood genuinely did dominate among many hunter-gatherer populations, most likely because it functioned well in settings where fighting off infections and maintaining physical endurance were ongoing daily demands. Genetic marker analysis tied to metabolism hints that there may indeed be subtle connections between blood type O and how the body handles certain nutrients, though nowhere near as dramatic as diet gurus tend to suggest. The bigger picture, blood type O isn't simply a genetic curiosity. It's a survival tale written across human history. From malaria-ridden swamps to ancient migration routes, from the rainforests of South America to the savannas of Africa, Type O carried people through some of the harshest chapters humanity has ever faced. It wasn't the earliest blood type to emerge, but once it appeared, evolution made certain it endured. So the next time you think of O as the blank blood type, keep this in mind. It's blank the way a shield is blank, not the way an empty page is. When it comes to blood type O and health, the conversation tends to feel like a jumble of science, folklore, and old wives' tales. You've likely come across claims that O types are naturally healthier, more physically capable, or even higher in energy. Some people call it warrior blood, while others argue that O types face greater vulnerability to particular conditions. So where does the truth actually land? Health, risks, and strengths. Thanks to decades of medical research and now artificial intelligence processing millions of patient records, a clearer picture is finally coming into focus. Let's begin with one of O's most well-known quirks, stomach ulcers. If you carry type O blood, you face a greater chance of developing ulcers triggered by Helicobacter pylori, the bacterium responsible for inflaming the stomach lining. And this isn't a minor association. Studies indicate that type O individuals carry roughly 30 to 40% higher risk compared to those with type A or B. The leading theory is that the absence of antigens in O blood somehow shapes how the immune system responds to H. pylori, essentially making it easier for the bacterium to take hold. Not exactly the warrior advantage people love to boast about. On the brighter side, type O individuals tend to show lower rates of certain cardiovascular concerns. Studies have found that people with type O blood tend to carry lower levels of von Willebrand factor and certain clotting proteins in their bloodstream. That might sound complicated, but the key takeaway is this. O blood is simply less prone to forming the kinds of dangerous clots that can set off heart attacks and strokes. Analysis of hospital records using AI backed up this protective pattern, showing that O carriers were less represented in serious clotting emergencies than people from other blood groups. So there really is a cardiovascular advantage built into type O. Another fascinating dimension involves fertility. For a long time, medical professionals observed that women with type O tended to show lower ovarian reserves compared to those with type A or B. Some interpreted this as a sign that O blood might work against fertility. However, when AI took a deeper look at records from fertility clinics, a more layered picture emerged. While O carriers may sometimes display lower egg counts, they don't actually see meaningfully reduced rates of successful pregnancies once treatments are taken into account. In other words, it's nowhere near as straightforward or alarming as it once appeared. The immune system side of this story is equally layered. People with type O blood frequently mount powerful immune responses, which may help explain why, historically, O types seemed better at holding off infections such as malaria. But that comes with a trade-off. Those very same immune tendencies can leave O carriers more susceptible to intense reactions when illness does strike. As one example, type O individuals have shown elevated risks of more severe responses to certain viral infections, including norovirus. AI models even detected subtle differences in how various O subgroups handle everyday colds and flu, pointing to the idea that O immunity isn't one neat superpower, but rather a blend of advantages and vulnerabilities. Now let's shift to personality theories, because this is exactly where scientific thinking and popular culture start bumping into each other. In Japan and South Korea, blood type is commonly treated much like astrology. Type O individuals are typically stereotyped as self-assured, strong-minded, and perhaps just a touch quick to anger. These personality claims might make for great party conversation, but they simply don't survive scientific scrutiny. AI text mining projects that cross-referenced personality surveys with medical records found zero consistent evidence connecting O blood to any particular character traits. Put simply, your blood type has no say in whether you're outgoing, timid, or the one everyone gravitates toward at gatherings. Apologies to the horoscope crowd. What isn't a myth, however, is the real-world impact O blood has on medical care. O negative remains the universal donor, and O positive continues to be the most abundant type sitting in blood banks. But AI has uncovered subtle mismatches, even within O-type transfusions themselves. Certain O carriers develop antibodies against lesser-known antigens, which can make some transfusions more complicated than anyone anticipated. That actually explains why a number of O2O transfusions in earlier years produced unexpected complications, something that left medical professionals genuinely puzzled at the time. Now, it's clear it wasn't unfortunate coincidence. It was hidden biological complexity that AI managed to bring to light. So where does all this leave things? If you carry type O blood, you're neither untouchable nor at a disadvantage. You may sidestep certain cardiovascular risks while facing more digestive challenges. You might show stronger resistance to malaria, yet experience a rougher time with norovirus. Like every other aspect of human biology, it's really a matter of trade-offs between strengths and weak points. What's genuinely exciting now is that AI can identify those trade-offs with far greater precision than was ever previously possible. The takeaway here, O blood doesn't crown you a champion or mark you as fragile. It simply makes you human, carrying your own distinct combination of protections and vulnerabilities, and AI is finally giving us the tools to understand that full picture. Speaking of champions, though, when it comes to one particular arena, type O blood genuinely earns its reputation. Hospitals across the globe depend on it every single day, frequently in situations where lives hang in the balance. For many decades, O blood, and O negative especially, has quietly served as the unsung hero of emergency rooms, ambulances, and large-scale disaster response efforts. But now, artificial intelligence is reshaping how we think about and work with this so-called hero blood type, showing that even type O carries layers of complexity that medical professionals are only beginning to understand. Let's start with the fundamentals. O negative is known as the universal donor because it carries neither A nor B antigens and also lacks the Rh factor. That combination makes it the go-to option when there simply isn't time to identify a patient's blood type. You think trauma surgery or the aftermath of a serious road accident. A single bag of O negative can be given to nearly anyone buying critical minutes. This is exactly why blood banks treat O negative as though it were liquid gold. Despite being carried by only around 7% of the population, O negative makes up a remarkably large share of emergency transfusions performed across the globe. O positive, while it doesn't carry the universal label, is actually the most widespread blood type in the world, which makes it just as vital in everyday practice. Given that close to 40% of people have O positive, hospitals require a constant and reliable supply to handle routine demands, everything from standard surgical procedures to complications during childbirth. Put simply, if O negative is the emergency hero, then O positive is the steady workhorse quietly keeping the entire system afloat. Here's where things get interesting, though. AI has demonstrated that the universal donor label isn't quite as straightforward as everyone once believed. Medical professionals have long been aware of occasional unexpected reactions to O negative transfusions. For years, those cases were dismissed as rare anomalies. Then AI-powered analysis of transfusion records collected worldwide began revealing a consistent pattern. Tucked inside type O blood are tiny antigen variations, too subtle for conventional lab testing to catch that can still trigger immune responses in the person receiving the blood. It doesn't occur frequently, but it happens enough to be significant. Today, AI-based algorithms are capable of identifying these fine mismatches, lowering risks, and making the entire transfusion process safer than it has ever been. Yet another major advance stems from AI's capacity to forecast how transfusions will turn out. Historically, doctors matched donated blood to patients based on ABO classification and Rh factor alone. But here's something worth thinking about. What if two O-positive donors aren't actually identical at the molecular level? AI systems trained on enormous volumes of data can now forecast how well a particular donor's blood will perform for a particular patient, taking into account everything from genetic variations to a patient's history with past transfusions. Think of it as precision matching, a leap forward beyond the broad categories of traditional blood typing. Organ transplants are yet another area where O blood has taken on a significant role. Since O carriers don't have A or B antigens, they're able to donate organs to a much broader range of recipients. The downside, though, is that O recipients can only receive organs from fellow O donors, which makes them among the most difficult patients to find matches for. AI is stepping in here as well, combing through transplant records to fine-tune donor-recipient pairings and lower the chances of rejection. The hope is that someday, AI might even assist in modifying donated organs through genetic engineering or lab-grown tissue, making O recipients far less exposed to rejection complications. And pandemics deserve a mention here too. During the COVID-19 crisis, shortages of blood became a worldwide concern. AI helped medical facilities anticipate sudden spikes in demand and manage their supplies, making sure CO-negative reserves stayed available for the most critical situations. Looking ahead, AI could support blood banks in planning months out, forecasting shortfalls based on everything from seasonal injury patterns to shifting population demographics in local communities. Perhaps the most moving dimension of O blood in medicine is the human story wrapped around it. Behind every unit of O blood is a real person, someone who rolled up their sleeve, often without any idea whose life they were about to change. AI may be transforming how we handle and match blood supplies, but the simple personal act of donating remains the true foundation of it all. And since O blood is always in such high demand, O donors carry a particularly meaningful responsibility. In certain countries, regular O-negative donors are even designated as priority donors whenever shortages arise. Science paints blood type O as a remarkable result of genetics and evolution, yet culture spins an entirely different tale. Around the world, blood types have worked their way into folklore, popular culture, and even daily choices. And when it comes to misconceptions, type O has gathered quite a collection. Some rather complimentary, others genuinely peculiar. Let's kick things off with Japan, where blood type goes far beyond a medical fact and becomes a full-blown cultural fixation. Since the early 1900s, a belief system known as Ketsueki Gata has tied blood types to character traits. People with type O are regarded as self-assured natural leaders, grounded and practical, though occasionally a bit headstrong. You'll come across job listings quietly favoring O candidates or dating profiles proudly announcing, "I'm type O." South Korea shares a strikingly similar enthusiasm, portraying O types as warrior-spirited, packed with vitality and drive. Of course, none of this holds up under scientific scrutiny. Text analysis powered by artificial intelligence confirms what earlier traditional research already demonstrated. No reliable connection exists between blood type and a person's character. Even so, the belief runs so deep that it genuinely shapes social dynamics, hiring decisions, and even romantic matchmaking. Myths may have no scientific grounding, yet they absolutely steer real-world behavior. Then along came the blood type diet, which argued that O individuals should consume high-protein meals because their distant ancestors were hunters. It sounded convincing enough, and millions of people embraced it. But modern research, including nutrition analysis driven by artificial intelligence, found very little to support the idea. While blood type does influence certain health tendencies, it certainly doesn't determine whether a steak or a salad serves you better. Your gut microbiome, daily habits, and genetic makeup carry far greater weight. Another widespread misunderstanding is that type O represents the healthiest or most original blood. In reality, O developed later as a mutation branching off from type A. While it does offer protection against particular conditions, it simultaneously increases vulnerability to others, such as stomach ulcers. The notion of O as some kind of pure blood type has even fed into fringe pseudoscientific ideas, promoting notions of biological superiority. Both science and plain common sense push back against these ideas. Blood types are tools for survival, not a ranking system for human value. Artificial intelligence is now stepping in to dismantle these myths by crunching enormous amounts of data. One study revealed that type O individuals do show marginally lower cardiovascular risk, but that gap disappears entirely once lifestyle factors are taken into account. Put simply, the choices you make every day count far more than whatever label your blood carries. So why do these myths keep holding on? It comes down to something straightforward. Blood type feels intimate, a ready-made tag that every single one of us has, saying you're type O, so you're a born leader, has a much better ring to it than you're type O, so you might face a higher chance of stomach ulcers. Culture feeds on narratives, and blood types serve them up willingly, even when the science tells a different story. Now, what shifts when we stop viewing blood type O through the lens of history and the present and start asking where things are headed? Artificial intelligence and the next chapter of blood science. If the last 100 years were about uncovering blood types, the coming century will be about peeling back their hidden layers. And who's leading that effort? AI. What was once a neat 4-category system is starting to resemble a vast, branching family tree with countless paths we've barely begun to explore. For type O in particular, the future is anything but straightforward. One of the most exciting frontiers is precision medicine. At the moment, most physicians work with broad blood group categories: O, AB, AB, positive or negative. But AI is revealing that even within type O, tiny micro-level variations influence everything from susceptibility to infection to how blood clots behave. Picture a future where your medical file doesn't simply read O positive, but instead carries a rich AI-generated profile of your precise antigen makeup and how it connects with your genetics, your diet, and your immune response. That kind of detail could reshape how doctors approach disease prevention, medication choices, and even personalized vaccine development. Organ transplantation, too, could be completely transformed. People with type O blood face a particularly difficult situation today. They can only receive organs from fellow O donors, which leads to frustratingly long waiting lists. AI is already stepping in to help, analyzing massive transplant databases to better match donors with recipients. But looking even further down the road, AI could work alongside gene editing tools to essentially recode donor organs, making them compatible with anyone. If that becomes reality, the long wait that O recipients endure might finally become a thing of the past. Another promising frontier is how we prepare for pandemics. The COVID-19 crisis gave us a glimpse of how blood type can shape how a disease unfolds, and AI was central to spotting those patterns. As new threats emerge, AI could rapidly examine how various blood types respond to unknown pathogens, giving health authorities a valuable head start in developing treatments and vaccination plans. For those with type O, that could translate into quicker, more targeted protection when the next global health emergency arrives. AI also has a meaningful part to play in personalized nutrition and everyday wellness. The so-called blood type diet is largely unsupported by science, yet there are genuine, subtle connections between O blood and gut microbiome composition. AI can comb through microbiome studies and dietary records to surface truly individualized guidance. Rather than generic health recommendations, O carriers might eventually receive lifestyle advice shaped specifically around their own biology. Perhaps the most thought-provoking possibility of all is that AI could fundamentally reshape how we understand blood types themselves. The ABO system feels clean and straightforward on the surface, but it really represents just one lens for categorizing blood. AI may reveal entirely new ways of classifying it, more detailed, more predictive, and far more medically meaningful. One day, being type O might turn out to be just the beginning, with something far richer and more precise taking its place. The future of blood type O isn't really about remaining simple or plain. It's about unfolding as a landscape of hidden depth, a detailed map that AI is only now helping us decode for the first time. Do you agree with all of this? Share your thoughts below and stay subscribed for more sciencing.